Hello, today I will demonstrate a laboratory exercise which is flow through a Venturi meter. This is our setup. We have a hydraulic bench. On hydraulic bench the key elements are pump, switch on and off button, water supply inlet valve and measuring tape to measure volume. On top of hydraulic bench we have a Venturi meter itself. Venturi meter pipe, you can see here, consists of three sections. Convergence section, which is reduction in diameter along the pipe, the throat, which is the smallest diameter, and divergence section. Along the pipe we have piezometric tubes connected, and we will be taking measurements for piezometric tubes from number 1 to number 6. Diameters for piezometric tube for each location along the pipe where piezometric tubes are connected are shown at the front of Venturi meter. A, B, C, D, E, F means 1, 2, 3, 4, 5. So these diameters you will need to calculate the cross-section area. These are our piezometric tubes. Behind the tubes we have measuring rulers, and these measuring rulers we will use to record piezometric head for each of this tube. At this stage, as you can see, the water level is the same in each of these tubes because we don't have any flow. At the end of the Venturi meter we have our discharge valve. So as soon as we start operating the system, the water will be pumped from hydraulic bench into this pipeline, going through Venturi meter and then discharging through this discharge pipeline. We will start experiment. The main objectives of today's exercise is to gain experience using Venturi meter, to calibrate Venturi meter, and to have better understanding of Bernoulli meter principle. Experiments consist of two parts. In part number 1, we study variation of piezometric head along Venturi meter. We will set up flow rate to maximum and we will record piezometric head at each tube. We start experiment. I push pump on button and I slowly open both valves together. So water supply valve and discharge valve. I slowly open simultaneously them together. And I'm trying to achieve maximum flow rate. Means that my number 1 should be as high as possible and my number 5, which is the throat, as low as possible. If it's not exactly at the top or at the bottom, it's still fine, but as long as it's close to 0 and close to around 300, it will be fine. You can see the changes and piezometric head, because as soon as the flow coming through a pipeline, there is flow. You don't see anything because there are no any air bubbles, but there is flow going through here and coming through the discharge valve. I'm almost there. You can see it's going down, that one is going up. You see it's too low. I need to adjust. A little bit adjustment that my water levels are within the scale. I will just open a little bit more to have a little bit higher flow rate. Maybe this goes a little bit down and this would be okay. And for this experiment, as I said, this is part number 1 and we study variation of piezometric head. So I will do recordings of piezometric head for each tube from 1 to 6. After that, we will measure flow rate. So my readings here is 290, 215, 135, 117. Here it's 0. Here we have around 145. And here is also, which is number 7, which I don't take this reading, but this is also around 145. After I have done all these readings, you record them in your table number 1, and then now we need to measure flow rate. To measure the flow rate, I close hydraulic bench tap. So my tap is here, you can see I close. This is how it's similar like in a sink. You close the tap. As soon as it's closed, the water will start filling in hydraulic bench, inside of hydraulic bench. And the water level here will start rising. This is our measuring tape. I will take measurements from the upper scale because this scale is too short, only from 0 to 6. And I will start recording when my water level reaches 0. Okay, so we are waiting for water level to go because we will be measuring from upper ruler starting from 0. As soon as my water level goes to 0, I will start my watch. My eye level should be on roughly the same level. So I started the watch and now I have to wait. Ideally, I have to wait for around 60 seconds, which is 60 seconds to have an accurate reading. So I will record until my water level goes to 10 liters, and then I will just stop. I hope it will be around 60 seconds. Yeah, it will be probably more than 60 seconds, and it's exactly 10 liters. The flow rate will have to be measured each time when we do subsequent experiments. Probably I can stop now, which will be my stop, and I measured 8 liters time it took to fill 8 liters. I just stopped at 8 liters because this is sufficient time. So now my part number 1 is finished, and we will start part number 2. For part number 2, what we do 5 more experiments. 5 more experiments we will be doing, going from maximum flow. This is the setup for maximum flow because I have maximum difference between number 1 and my throat, which is number 5. I will be reducing the flow rate by slowly closing now both valves together. When I slowly close them both together, this water level will go down, this water level will go up. You can see it goes up and this water level goes down. And this would be my second experiment. For part number 2, we do collect data to do calibration of Venturi meter. For part number 2, we only take readings at piezometric tube number 1 and the throat. And also we need to measure flow rate again. Each time, for each additional experiment, we measure flow rate. Because now the flow rate is smaller compared to previous experiments, we need to measure this. I won't be measuring again because I did show you how to measure, but each time you measure. So in this experiment, we take reading of around 233 and around 16 millimeters, and then we measure flow rate. Then my third experiment, will be again slowly closing this together simultaneously. I reduce again flow rate because you can see the difference between number 1 and my throat is reduced again, and this is reduction in flow rate. I take the readings of around 205, and here I have around 97. No, it's 95, around 95 mil. This is all in millimeters. And then I measure flow rate again. Then I do another experiment, 5 more, as I said, 5 more experiments. For my last experiment, I try to set up the lowest flow as possible, and for this lowest flow as possible. So what I'm doing now, I'm slowly closing both valves, water supply and discharge valve together. So by slowly closing them, I reduce the flow rate, and you can see, I assume that this will be my this will be my lowest or minimal flow rate, because my difference between number 1 and the throat is quite small. Here I have around 170 millimeters, and here I have 140 millimeters. So the difference between those two is around 30 millimeters. And for 30 millimeters, I assume my flow rate is the minimum. Obviously, I can do smaller, 10 millimeters, for example, but 30 would be good enough. And again, I take the readings, 170, and here 140 mil, and then I measure the flow rate again. And here, it will take much longer to fill because the flow rate is reduced. So in total, you have 5 more experiments in addition to experiment number 1, and you will use this data to calibrate Venturi meter. I will prepare another video to show you how you do data processing after you have done the lab. To switch off equipment, I just close both valves together. Up to the maximum, there is no flow coming through the pipe, and I switch off the button. It's finished. Thank you very much.